Here I've got a 1951 to 1953 Zenith Transoceanic H500. It's in pretty good shape, except the outside cabinet is, the color's gone from a lot of it, but it isn't scuffed. It's in good condition. So as with the earlier Zenith Transoceanic, it can be restored with shoe dye and made to look very good. This radio has a crack at the top here, but other than that, it's in good condition with all its original dials, and everything seems to work except there's no sound coming out of it. I use this radio for the sound, as I said, would get worse and worse. The quality of it wasn't as good, and it would start to drop out, and then it went completely. And now I plug it in and you can't hear a thing coming out of the speaker. So when it pops in and out like that, that's usually indicative of a bad coupling capacitor. But you just never know. So I'm going to go into this radio and figure out what's wrong with it. As you can see here, it looks like this radio is all intact and very clean inside. A little bit of rusting up right there. You can see a bit of rust. And there, that one isn't rusted as much. And down here, some of the Tolex or whatever that coating is, that material that it's coated in, leatherette I guess you could call it, is starting to come away, so they'll have to be glued. An interesting feature of this radio, as with the earlier ones, if you wanted to switch to battery operation, you take the plug and you plug it in here, and then the radio is, then you plug in the battery connections. Although I will never do that, but it's always interesting to note that most of these earlier Zenith Transoceanics had that feature. In this repair, I'm also going to restore the outside cabinet to make it look as good as it possibly can. When you take the chassis out of the cabinet, it's quite flimsy, so you have to be careful how you do this. This attachment to the whip antenna needs to be taken out, and here are two connections that connect to the wave magnet antenna. That's for AM radio, and those need to be taken out very carefully. And also underneath, I'll push this over here. You can see there are two nuts, look like nuts anyway, that need to be taken out. Those are quite often, usually one is lost, but it doesn't look like this has been worked on, so we'll just hope those are the original, but they seem to fit in very well. So I used a pair of pliers to gently take this off from there, and this one gently just pulls away. You just grab hold of this red holder and they pull right out. Now the only thing I need to do is remove the screws underneath, or nuts. One convenient thing Zenith did was they drilled holes in the bottom of the cabinet so that you could fit a nut driver in there. There's the one and there's the other hole. I was wrong. Somebody has been in there and lost one of the screws. This is the original and this is the one they added. Never fails. There's always a missing one. One thing that you really have to be careful when you take the chassis out is right here you have to take this side out first and kind of ease it out, because these, you have to watch that you don't knock these very delicate coils. If you bend them, you're going to have to do a frequency alignment. So you have to really be careful when you take these apart. Now I see that this latch up here is blocking my taking the radio out. So I'm going to have to take that latch out. You have to be so careful when you take this chassis out of the cabinet. You have to make sure you don't touch the speaker cone because it's so delicate. Everything else is pretty solid. I can see here very quickly what work has been done. The selenium rectifier has been bypassed with a diode. And I can't see anything that jumps out at me. Maybe that one was replaced. These could have been replaced, but they did a very nice soldering job. It blends right in with what was originally there. So it's kind of hard to speculate. Here are all these capacitors from the 50s that are notorious for going bad. So anyway, I'll go through this and check and see which ones have gone bad. I've learned from previous Zenith Transoceanics that just do the least work that will get the radio working, because you can do so much damage to those tubes. You can destroy the tubes so easily because they have very, very delicate filaments. So to this radio, I'm just going to replace the parts that are necessary to get it working again. I'm not going to do extensive renovations to it. The capacitors will go as they need to go. I'm not going to do a radical recapping like I do on other radios that I know it's not going to do any damage to the tubes. So anyway, I'll get on with it and go through the circuit. One thing about this radio is that it, when I used to listen to it, it had no hum. It was very quiet. The only problem was that the sound was a little distorted. That was the only problem I noticed. It had great sensitivity. So I'm not going to worry too much about anything as far as filter capacitors or anything. They seem to be okay. I'm just going to look into those coupling capacitors first. And then I'm going to test all the tubes. But the number one thing I'm going to do is print out a schematic diagram, and I'm going to go over that. Okay, so I've taken the tubes out and I'm testing them. So this tube that I'm testing is 3V4, and it should be 1040 to 1650 micromodes. That tube is very strong. So there I'm testing the next tube, which is in the It's the driver to that final audio tube that tested out good, a 1S5. And the first section of it is completely dead. So that tube will need to be replaced. I've put a new tube in, which is good, perfect. And now I'm going to test this tube and this tube, the 1U4s, and then I'll test the expensive tube, the 1L6. Hopefully none of those tubes. I have these, I believe I have these, but I don't have a replacement for that. So we're out of luck, or I'll order a solid state replacement for that tube if it's gone. So anyway, the 1U4 is the next one. And by the way, I'm not going to fire the radio up with that that new 1S5, because I figure the way the radio was acting, it was popping back and forth. It was making a popping sound, and the sound would go away, and then it just finally died. So what I assume is that there's a bad capacitor in there that took out the tube. So I'm going to take out all the tubes, and I'm going to test it with a high voltage tester. I'm going to test each of those capacitors with the tubes out, of course, before I retube it. So I've got the first 1U4 in there, and it should measure 570 to 900 on the 3000 scale, measuring the highest in the range. So that one's very good. Take that one out and put the other one in. Let's see here. They're instant on, so you don't have to worry about heating up time. And that one's pretty good. That one's about almost 900. So both those tubes are good. Here I've put the 1L6, the very expensive tube, in the socket. And it should measure 1L6. Let's see where we are here. 520 to 825. That's on the 520. Very strong. Okay, now I'm going to test the next section of it. I checked the pentode section of the 1L6, and now I'm going to check the oscillator section. It should be at least 300 on the 3000 scale. Yeah, it's a little low, but I think it should be okay because it was working before. I was thinking about the best device I could use to test out those capacitors for leakage, and I thought about this device I haven't used in a while. I made a number of years ago, and it's basically a megger. It will put out up to 1000 volts DC, and the scale there will show you how much current the capacitor is letting through. Now I'm going to set this at 150 volts, and I'll just show you how it on a meter. 148, and this capacitor here, the brown one there, it's 600 volts. It's the one that's across the line, and I'm just I'll test it at 600 volts and see what how much leakage it has. See if I can even get it up to that. Now I can't get it up to 600 volts, but it's leaking 325 microamps, which is fairly substantial, but it's when these capacitors really break down, they really break down. So anyway, I'm going to reset it for 150, which is the maximum voltage that is in this radio, and I'm going to test them all at 150. So we'll go back to 150. There we are, 160. I'll just leave it at that. Give it a rest. Now I'll go to the next capacitor. Oh, I'll do that again. That capacitor is letting through 100 microamps at 150 volts. So now we're going to check the white capacitor there. Negative goes to the side that says foil, and put 150 volts across it and see what happens. Got about 50 microamps going through it. That's nothing too crazy. The next one we're going to check is that black capacitor in there. It's right in the audio output area where that tube failed. The tube was a first amplifier and a detector, and it's this particular socket that I'm looking at right now. That's not directly connected, but it would have an effect on the output tube. So let's see what that says. Okay, that one is completely gone. So there's our problem. That's what caused that tube to fail. That is a completely open capacitor. It lets through the maximum current. So I was mistaken. That capacitor, which is that one right there, it's on the output of the power amp. So it's between 2 and 3. So it's a 0.01 microfarad. So I'll replace that and go on to the other capacitors. I don't believe that would have caused the failure of that other tube. That other tube was probably just bad. It burnt out. And the intermittent was this capacitor breaking down. The tube that failed was this one here. But I don't see how that failing would have caused this filament to break. The filament was open, and that was what was causing that 1S5 detector amp to fail, or to not work. Now that I've got that capacitor out, it just has a moderate amount of leakage at 150 volts. It's across the output transformer. It's basically for cutting out the highs, and just moderates the tone a bit, and also protects the speaker. It acts as a damper because the output voltage, when that pentode is working into that coil, it can get some pretty high voltages with back EMF. So that capacitor dampens the reverse EMF, and it basically protects the tube too, so that there isn't any arcing. So what I'm going to do, since I've taken that out already. I'm just going to replace it with that 250 volt rated capacitor, and it's a 15 nanofarads, which is pretty close to the one that's in there. Looking at the schematic, I can see why that capacitor was pegging, because it's in parallel with a coil. So the 280 ohm coil, which is the input of the output transformer, the primary, was basically shorting the capacitor out. But nevertheless, that capacitor is quite leaky, so it was a good thing that I replaced it. The next capacitors I'm going to check are those two ceramics. That one there and that one. They basically take the signal from the middle wiper, the wiper of the volume control, and the first one applies the audio signal to the driver tube, and then the output of that, after it's amplified, is applied to the input of the power tube. So we'll see how those are. If either one of those are leaky, that could have affected the audio when I was hearing it becoming muddy and clicking and all that sort of thing. But so could the one I replaced. So let's test these at 150 volts. The input one I'm testing with 150 volts across it. And I'll press the button. It charges up and then goes back down again. Almost no leakage. Now I'm going to test the input one to the power tube. There we have about 50 microamps, although that could be going through resistors that are in parallel with it. So that's very low. I'm not going to worry about that. So the next one I'm going to check is this large black capacitor here with the bands. So one end of it is tied to the chassis. Okay, that's 150 volts. Oh, that's unacceptable. So I'll have to replace that. So basically the purpose of that capacitor, it's that one there. And that's chassis, that's the metal chassis of the radio. And it ties, it goes to, let's see, here. And these represent the capacitors that are in that can I tested earlier. They are not tied to the chassis, as would most AC radios. This represents the metal can of the capacitor, the electrolytic capacitor, with the 4 different capacitors in it. And so basically what that capacitor does is it ties that to, it gives a path for the AC. So any AC noise or anything, it just passes it to the chassis, which is, so it gives it an AC ground. So there's not much voltage across that, but I'm going to change it anyway. It's a 0.047, which I'm going to replace it with a 0.05. The high DC leakage could be caused by it leaking through the higher voltage DC capacitors that it's connected to. But I think considering how these are basically 75 years old now, I'll just change them as I see them. So here we're going to test some more capacitors. this one down here. I'm going to test that at 200 volts, 150, sorry. That one's okay. So now we're going to test this one. That one's fine. Now we're going to test this one here. That's fine. Now this one here had me worried when I had it connected to the circuit there. Right there. Pulled away, I clipped it off, and it's quite normal. When it was connected, it had me a bit concerned there because it practically pegs. But the leakage through the capacitor itself, when it's removed, is just quite normal. Now I'm going to check that ceramic capacitor. And 200. So I'm not going to worry about that. One thing when you're starting to check around the RF section, there's a lot of coils and low value resistors, so you can be misled. So what I'm going to do is I'm going to return this, I'm going to resolder this back on, and I'm going to check these two in the audio section, which I doubt are going to give any problems, and these two domino capacitors, and then that's it for the capacitors. Here I'm going to check the upper one there of the two banded capacitors. That one right there. And quite a bit of leakage, but of course there's lots of resistors in parallel with it. That's just the tone control. So next we're going to check the next lower one. Okay, now we're going to check that one. And it's not shorted, so I'm not going to worry about that. That's just in the tone circuit. So now I'm going to check that domino capacitor down there. And I'll press the button. Doesn't even give me a response. So there's almost nothing leaking through there. Undetectable. So there is the other domino capacitor. And I'll check that. Nothing. So we've checked all the capacitors, and they don't seem to be causing a whole lot of problems, except there's some leakage. But now, since all the problem was caused in this area, I'm going to check the resistors on the two output tubes and see how they are. So I'm checking this 10 meg resistor. It's 13, close enough. That's just for the filament on the output tube. I'm measuring the 270 ohm resistor, and it's 349, a bit high, but it should be okay. So there I'm measuring a 1 million ohm, 1 mega ohm resistor on the output tube, and that's what I get, 1,083,000 ohms. That's okay. Okay, so that resistor right there is 15 megs, and it measures 27 megs, so that should be replaced. That 4.7 meg resistor measures 4.9, that's okay. That 1 meg resistor there comes out at just under 1 meg, so that is okay. So I was a bit suspicious of that that digital meter reading 27 meg ohms for that 15 meg ohm resistor down there. So I thought I would just use a vacuum tube voltmeter, which are much better for these high ohm ranges. And look what I'm measuring, 16 meg ohms. So that's close enough. One advantage to the vacuum tube voltmeter is that you adjust it each time. You adjust the bridge circuit. You let it warm up and then you adjust it. You adjust 0 and you adjust infinity. And it comes out very close to the 15 meg ohms. So if I'd relied on that other meter, I'd have replaced it. I don't have one, so it's good that I double checked it. 15 meg ohm resistors I don't normally have. I'd have to go out and order one. So anyway, that is not a problem. All those resistors seem to be within specs, and the capacitors around the tube that I replaced seem to be okay too. So I think I can put the tubes back in their sockets and fire up this radio. So I've put all the tubes back in the radio, turned it on, and I don't get anything from the loudspeaker. So I thought what I would do is check the two output tubes. I wanted to feed a signal into the driver tube right from the volume control, right here at this point, where it'll go into the grid of the driver tube and pass a signal to the next tube. So basically what's happening right now, I am feeding a signal 1 kilohertz, 500 millivolts peak to peak, and at that point, and I don't hear anything. So I'm going to go to the input of this tube here, right here, and see what happens. So I'm now feeding a signal into here, this point, and I can hear a 1000 hertz tone coming out of the speaker. So that means that this tube is working. There's something wrong with this tube, or one of the components around it. So this tube actually is good. I've replaced it and I've checked it a couple of times on the tube tester, so it's fine. So I'm going to do some voltage checks. So I'm going to check voltage here, which should be 24 volts. So here I'm taking the voltage from the plate of the driver tube, and it should be 24 volts. And I'm only getting 0.173 volts. So something is dragging that voltage down somewhere further up on the power supply. I'll have to find out what that is. You can see my alligator clip there, which is the positive lead of the meter, and it's on one side of that 4.7 meg resistor. Now on the other side should be 24 volts, and I know that resistor is good. I just checked its resistance, so it's not changed value, and so there should be a voltage drop across there, and here's what the voltage I'm getting on the other side there, 3.2, still way below the 24 volts what should be on the plate. If this was working properly, that voltage will be way above 24 volts. So the problem is somewhere further down the line of the power supply. So that brown capacitor, it's an electrolytic. It says 12 microfarads, and I measured it somewhere around a bit over 6. And I thought it might be okay. So I'm measuring, that's the smoothing capacitor for that low voltage circuit. So I'm measuring the voltage on the end there, and it's at the same potential as what we had before on the opposite side of the resistor. So I'm going to look into this further and see other parts of that circuit that might be dragging it down. So I was getting a smelling, like a burning resistor smell. So I thought I'd take out this FLIR meter. It shows you anything that's dark or red is hot. So I'm going over the power supply. That resistor I expect to be hot. Now I'm just going to go around. There's something else hot there, a resistor. And see here. We have a bunch of hot ones there. Interestingly enough, anyway, I know there's some hot components here. I saw some smoke coming from that area. So the resistor that was getting really hot was this one here. It's a 68,000 ohm resistor, and it's gone out of tolerance. You can see that the bands are almost completely gone. So that will have to be replaced. Now what I did, that I found out looking at the schematic that the brown capacitor feeds all that. So I took this off, and the voltage in this area, it's fed from elsewhere, but this obviously smooths it out. So I lifted this up, disconnected it from the capacitor, and the voltage just shot up. So I've determined that the problem is this capacitor here. It isn't smoking or anything, but it's drawing enough of the current to overload that circuit. So I'm going to replace that capacitor and also that resistor, and hopefully then that will the voltage will return to normal, because it's not the tubes. All the tubes are good. So now that I've replaced that electrolytic capacitor, some things have changed. I'm getting 80 volts on the plate of the detector tube and first amplifier. It's all in one package. And I also put a scope on the input to the detector, and I'm getting a good healthy signal that changes when I tune into stations. So the only part of this radio that isn't working, that's weird, is that tube, the driver detector tube. So I'm in a bit of a dilemma as to what is causing this. I've checked all the resistors and capacitors around there. All the resistors are of the right value. They haven't drifted much. And the capacitors are fine. The input capacitor is okay. I get nothing when I touch it. There, get nothing. But when I touch the input, this capacitor here, where are we here? Right here. Definitely get something in the output of the audio. So what I think I'll do is I'll just take the tube out and resolder all the connections and see if that makes any difference. I tried resoldering all the connections. That quite often will solve problems like this, but nothing changed. So I'm going to have to think about this for a while and come back to it. I thought I would just do something kind of neat. I took the signal, the IF signal, from the output of the final IF amplifier, just before it goes into the detector, and I put it through a capacitor to a germanium diode, and then I took that output and I put it into the final tube. And it's not very sensitive, but I am receiving radio stations with okay tone quality. No sensitivity though, but the radio is good tone, so I'm just going to concentrate on that that first amplifier and detector, see what's causing that problem. I've been looking around the underside of the radio for possible shorts that might be shorting that 24 volt line to the higher voltage line, and I've found a dead short here between you've got, it's right in the RF amplifier, no, it's right in the IF amplifier tube. There's the RF amplifier. Okay, so now I've removed that solder bridge, so now I'm going to fire the radio up and see if the voltage is still the same on that driver tube. Surprisingly enough, that made no difference. We're still getting 80 volts on the plate of the driver tube. So we're going to have to look elsewhere.